Here is the first example where we're going to try and unravel an integral involving trig functions. Now when we look at the integrand in this particular case, you'll notice that it involves two trig functions, but each of them is raised to a power. So each of those two pieces can be thought of as a composite function. For instance, cosine cubed of x can be thought of as cosine x as the inside and the cubed as the outside. So that's a composite function that suggests possibly a substitution. And so is sine squared of x. We can think of sine x as the inside and the square as the outside. But the choice here is actually one way only. Why? Well, notice that the derivative of sine is equal to cosine, and we have three powers of cosine, or if you want, you have a power of 3 for the cosine. So what we can do is we can use this odd power of cosine x for a substitution. So what substitution are we going to use? Well, we're going to let u equals sine x and du equals cosine x dx. So notice that the u will be taking care of the sine squared of x, and the cosine x will be coming from one of the three powers of cosine x. So let's see how that works. So we're going to rewrite our function. First of all, we're going to rewrite the integral. Instead of cosine cubed, we're going to write it as cosine squared of x times cosine x, and then we have our sine x squared times dx. So as we do the substitution, the sine x becomes u, the cosine x dx becomes du. Notice that I'm doing a little bit of a shortcut here. I'm skipping the step where you're supposed to find dx in terms of du, and I'm just noticing that cosine x dx together form the du. Therefore, I change that to u squared du, coming from the last three factors in the old integral, and I'm still left with cosine of x squared. Well, what am I going to do with that one? At this point, remember, I cannot proceed with integration because the two variables are both present. So I still have to get rid of the old one. Well, what we can do here is we can use our basic trig identity, which tells me that cosine squared of x, as you remember, is 1 minus sine squared of x. And since sine x is our new variable u, that is all equal to 1 minus u squared. So now we change our cosine squared of x to 1 minus u squared. And now we're dealing just with a polynomial. All we need to do is a power rule, which will give us this antiderivative. You may want to pause and check it on your own. Of course, we're not done yet. We have to go back to the original, but that only involves changing every u in there, or each of the two u's, to sine x. And here we've got our full indefinite integral.